This is lesson 6-1, angles of a polygon. So this little chart that you have on your notes has a few of the polygons, and you should be able to see a similarity or a correlation between the number of sides a shape has and the number of triangles within the shape. Now, when you're making your triangles, it's very tempting to want to cross diagonals and say, well, I see 4 triangles. But you cannot cross diagonals when counting triangles. So you should be able to see that no matter how many sides a shape has, there's always 2 less triangles that you can make inside a polygon. So if we say that any sided polygon has n number of sides, it always has 2 less triangles, so n minus 2. To find out how many degrees all those angles add up, each one of these interior angles, you should see a pattern that outside is the number of triangles, so n minus 2, and every triangle has 180 degrees in it, so we're going to multiply that by 180, and that will equal how many degrees are in your polygon. Okay? If you need to remember what some of the polygon names are, like for example, in example 1 we have the word nonagon. If you don't remember how many sides a nonagon has, you can look at it in page 390 in your book. It goes all the way up to decagon, which is 10 sides. Okay? Example 1, we want to know the sum of the measures of interior angles. So that tells us to use this formula. We need to know, though, how many sides does a nonagon have? If you don't know, you can look it up on page 390, and you will see that a nonagon is a 9-sided shape. We don't know what it looks like. It could look like any shape with 9 sides. We don't care, but we do care how many degrees are in that shape all together. So if we use this formula, we have 9 minus 2 times 180. Well, 9 minus 2 is just 7. So on your calculator, you can figure out what 7 times 180 is. And you should get 1,260 degrees. That's how many degrees all 9 of those angles added up equal. Okay? Example 2. We want to find the measure of each interior angle. So we have a parallelogram, which is also a quadrilateral. Since a quadrilateral has 4 sides, all 4 of those angles add up to 360. So we know that all 4 of these are going to add up to 360. So let's write an equation. Let's add them all up, set it equal to 360. 11x plus 4 plus 5x plus 11x plus 4 plus 5x equals 360. What we have to do is combine the left side. It looks messy, it's ugly, so let's gather all of our x's and all of our constants together. You should get 32x plus 8 equals 360. Now we just got to solve for x, so go ahead and solve for x. Okay, you should find x equals 11. Is that what we wanted to know? No, we are asked to find the measure of each interior angle. So we need to plug it in. Now you should notice angle S and angle U are exactly the same. So they are going to equal the same thing. We only need to plug it in to one of them. So 11 times 11 plus 4, that's 125 degrees. Okay? Angle R and angle T also are exactly the same. So we only need to plug it into one of those as well. 5 times 11, 55 degrees. Now how could you double check to make sure your math was right in here? Well, adds up to 360. 2 of these plus 2 of these had better equal 360 or something went wrong in your math. Always double check just to make sure. Okay, go ahead and turn the page to example 3. And we have here a pentagon-shaped food court. We want to know the measure of one interior angle though, not all of them. Now there is a key word in here, regular pentagon. You have to remember from pre-algebra what regular means. If you don't remember, look it up, or you could just listen. Regular means all angles and all your sides are the same. So if all 5 of my angles are the same, if I know how much I have altogether, I could divide to figure out what just one of those angles are. So I need to know how much I have altogether though first. So let's use our formula. A pentagon has 5 sides, so we'll plug it in to our little formula, n minus 2. So that gives us 3 times 180, which is 540 degrees. Remember, that means all 5 of these add up to 540, but I only want one. So to figure that out, let's divide it by 5. You should get 108 degrees. Awesome. Example 4. We're going to kind of use example 3 as reference. Okay, we want to know how many sides we have. So while we have this 150 represents the answer that we got in example 3. It's what it equals, one angle. So we know that it equals 150. Now let's think about what we did to get 108. To get 108, we divided by 5 because there were 5 sides. Now in our example 4, we don't know how many sides. It's asking us to find the number of sides. So since we don't know, we're going to call it n. And then let's think about how did we get 540? We used our formula, our n minus 2 times 180. Now that we have an equation, we can solve for n. So it looks really messy on that left side. Let's clean it up a little bit. Let's undo this division by n by multiplying both sides by n. That will give us n minus 2 times 180 equals 150n. Okay, left side looks a little better, but we still can clean it up. Let's distribute that 180 to both the n and the -2. So we get now 180n minus 360 equals 150n. Hey, that's so much easier, because now I can solve for n. Let's take that 180n over to the other side. And go ahead and solve for n. Make sure that you notice you have a negative divided by a negative, which makes sense because you cannot have a negative number of sides. It's like being negative 2 feet tall. Doesn't work. Sorry. N equals 12. So what does that mean? That means the number of sides. This is a 12-sided shape. If you don't remember what that's called a dodecagon. Has 12 sides. That's our answer right there. Now, up until now, we've always been talking about interior or inside angles. There are exterior angles. If you look at example 5, picture each side as it goes on, a line goes on forever. So it creates these little angles on the outside of your shape. Now the cool thing about exterior angles is it doesn't matter how many sides you have. You could have 3 sides, you could have 1,000,000 sides. It really doesn't matter. Every single polygon, the outside or exterior angles will always add up to 360. Always. Remember that. How many degrees? 360. You might be asked that tomorrow in class. So if we want to find the value of x in example 5, we have a bunch of angles. We have 7. We know that they will all add up to 360. So let's just pick a spot and go around and add them all up and set it equal to 360. So let's write our equation. Okay, that's a really long equation. So, let's get all of those x's together on that left side, because that looks horrible. And I don't know about you, but it takes up too much space. So, add up all your x's and add up all your numbers. You should get 31x minus 12 equals 360. Go ahead, solve for x. Okay, you should get x equals 12. Is that what you wanted to know? Yep, it says find the value of x. So we can stop there. That's all we wanted. Alright, our last example. Find the measure of each, that means one, exterior angle of a regular decagon. So, what is a decagon? Think of a decade. It's 10 years, so a decagon has 10 sides. How many degrees are altogether on the exterior? 360. And if we have 10 sides, to find one of these angles, let's divide it by 10. We will get 36 degrees. Excelente.